let's take a look at this one together. Before we get started, I posted, it's hard to see on the camera that I'm a little bit too close with my camera, but I posted a sheet of graph paper for you. So if you're able to print and you would like to use this graph paper, it's posted right next to the lecture videos. If not, you can freehand it, or maybe you've got graph paper already. That's what I'm going to use to do the graphing once we go through the properties. Okay, here we go. Part A, f of x equals negative x squared minus 4x plus 12. Let's try it out. So, step number one, property number one, is to determine if the parabola opens up or down. Well, maybe I'll just ask you guys, would the parabola for this function open up or down, and how can we tell? Property number one, we look at the value of a. Here a equals -1. And because it's negative, we know that that parabola is going to open down. Okay, done. Let's move on to property number two, the axis of symmetry. How do we determine the axis of symmetry again? It's -b over 2 times a. So I'm just going to go ahead and show you my work. X equals negative, b is -4. Negative 4 over 2 times -1. All right. Negative b over 2a gives me positive 4 over -2, which is -2. So I'm going to say the axis of symmetry, is the vertical line located at x equals -2. So far, so good. Okay, property number 3 is to determine the vertex. So I already know the x-coordinate of the vertex is the same as the axis of symmetry. So I'm like starting off over here, probably is a better place to begin. I know my x-coordinate's -2, but I want to find the y-coordinate. Well, how do I find the y-coordinate? I can take the -2 and plug it into the function. My function way back from the beginning. So I've got -2 squared minus 4 times -2 plus 12. Tells me the y-coordinate. So plugging that in, let's see, this would be positive 4, but then it's negative, so -4 plus 8 plus 12. That gives me 16. So my vertex is the point -2, 16. Hey, we're moving along pretty well here. Okay. Let's go on to step number 4. Step number 4 is to determine the Y-intercept. So what we're going to do is plug in 0 for x, and we're going back to our function, plugging in 0 for x, both x's. And I'll just let you guys see all that work. We're not ready for this part yet. Let me cover that up. Okay, so we're plugging in 0, calling it y equals, putting in 0 for the x's, and well, 0, 0, y equals 12. So our y-intercept is the point 0 for x and 12 for y, 0, 12. That'll come in handy when we go to graph. And finally, property number 5 is the x-intercepts. We're going to do the opposite of what we did with the y's. We're going to set the y equal to 0 in the function. 0 equals -x squared minus 4x plus 12. And we're going to solve that. Of course, here we can just go for the quadratic formula. A equals -1, B equals -4, C equals 12. So I've just plugged those in, being careful with my negatives and my negatives squared. Okay, -4, plus or minus the square root of the quantity, -4 squared, minus 4 times -1 times 12, all divided by 2 times -1. Okay, so simplifying, I see I get a +4. This in the denominator is -2. Turns out all this works out to just be 64, which I like because I can take the square root of 64. And I continued over this way. Square root of 64 is my 8. And then, oh, looks like I've gone off the screen. I wrote the two separate equations. X equals 4 plus 8 over -2. And x equals 4 minus 8 over -2, and then simplifying each of those, I've got x equals -6, and x equals +2, and so I can write the x-intercepts as maybe -6, 0, and 2, 0, which I can graph here. In just a moment. So, okay. Hopefully you wrote all this stuff down, because now we're going to go to our graph paper and plot it all out. So if you did not already, I would recommend maybe back up the video, write all this information down, because we're not going to obviously be able to see it when we grab our graph paper here. So let's do this, and I think I'm going to move the camera up a little bit so we can see a little bit more of this in the same shot. Okay. So you might be using your own graph paper, that's fine. Here's what we're going to do. So I'm going to be a little bit strategic here. I'm going to find the center of my graph paper, and I'm going to draw a nice bold line to be my y-axis. And oh, that's not coming through very well on the camera. I'll try and make it a little thicker. That's pretty good. That's pretty good. You can see that. Okay, so I've made my y-axis. Turns out our vertex is kind of high up, so I'm going to make my x-axis way down here. Now, on your test, I'm going to provide you with a grid that you can easily just plot what you need to. But that's not the case here in lecture. Okay. So I'm just going to go through the properties one at a time and graph what we can, and then, you know, hopefully it'll all come together. So we determined that the parabola opens downwards. Well, I can't graph anything with that, but I'll know that in the end it's supposed to curve downwards. What I can do is graph the axis of symmetry, x equals -2. So I'm going to find -2 here on the x-axis, and I'm going to graph a dotted or dashed line here at -2 all the way up and down my page. So this invisible line, if you will split my parabola in half. Okay. Now I'm going to plot the remaining points that we found. So we know the vertex is at -2, 16. So we know that we're on the axis of symmetry, but it's all the way up at 16. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16. Okay. Oh, I lost count. It's way up here. So that is why I had to shift my x-axis to not be right at the center, because my vertex is so high. So that's 16, and then we're at -2, 16. Okay, property number 4 is the Y-intercept. We found that to be at 0, 12, so we'll just count up 12. It's right here. And finally, we found x-intercepts to be at -6, 0. Right here, -6. And +2. And those are also symmetrical about our axis, so that we know we're on the right track there. Okay, it turns out there's actually one more point that we can plot, even though we didn't calculate it as part of the properties. Notice your x-intercepts are mirror images, right? They're both a distance of 4 away. You could do the same thing here with the y-intercept. You can plot a symmetrical point right there on the other side of the axis. So even though we never found that point ourselves, we still know that it must be there. And yeah, now we're ready to graph, and we can tell, yep, if we connect all of these points, it's definitely going to point downwards. So now it's just a matter of drawing it. Make sure that it's nice and curved at the top. It's not a V shape. And you know, feel free also to take some artistic freedom a little bit in the curve. Okay. And just go for it. So there's my curve, and I kept extending mine downwards. But there is the graph of our parabola. Well done. Okay, we're going to end this video here. We will do another example in the next one, and I'll have one for you guys to try out as well.